Hello, geometry students. In this lesson, I'm going to be talking about the concept of rotational symmetry. And what that means is if you have a figure like an isosceles triangle that maybe has a little point at the top, if I rotate this figure, in this case, if I just rotate it down here, I'll actually see the same figure. And then if I were to take it and rotate it some more, I could see the same figure again. And then finally you rotate it back home. So in the course of a 360-degree rotation or spin, I actually see the figure reappear 3 times. Once in the original blue, and then once when it's down here, the purple, and then finally down here for the green. That's what rotational symmetry means. It means it's symmetrical if you rotate it. Many things don't have rotational symmetry. Before we do that, though, I'm going to talk about just the concept of symmetry itself. Symmetry, the line of symmetry is the line that where if you fold this on itself, it'll fold onto itself. So this one has a line of symmetry there. That is not a line of symmetry because the top does not match up with the bottom. So this only has one line of symmetry. The starfish, a 5-sided figure, has 5 lines of symmetry. So 1, 2, 3, 4, 5. Don't be confused by this. This is just the tail end of that other line. So you can actually fold it along any one of those lines, and you will see a mirror image. The orange wedge, it looks like I have them there, but I also have these. So I have a total of 8. Butterfly only has 1. Be careful about this last one. It looks like an isosceles triangle, so I would think it has 3. But the fact is, this has none. There are no lines of symmetry on this. If you think about it, there's no way you can fold this on itself because you've got the arrow here, but not the arrow there. So no line of symmetry on that recycle symbol. All right, we'll sketch lines of symmetry just like I was doing. So on your pentagon, you should have 5 lines of symmetry. They start at the point and they go through the opposite side. So 1, 2, 3, 4, and then where's the last one? There's 5. So looking at the points, a 5-sided figure that's actually a regular pentagon should have 5 sides. I'm going to compare that with the hexagon. 1, 2, 3. But I've also got from the side, middle of the sides, so I have a total of 1, 2, 3, 4, whoops, counting these wrong. I have a total of 6, 1, 2, 3, 4, 5, 6. Well, how about this trapezoid here? I obviously have a line of symmetry here, but that's it. I don't have any other line of symmetry. If you try to do it this way, it'll fold in on itself. It'll look something like that. So there's not a line of symmetry up and down on this trapezoid. This one says write the equation. Well, there's one line here, and there's one line here. You just need to be careful about which one is which. Vertical lines up and down are x equals, and that's because they have a little v in them. So x equals, in this case, 1. That means these must be horizontal lines. That's because they form a little y equals 2. So the lines of symmetry, x equals 1, y equals 2. How about this one? Y-axis, x-axis. Is that all? If you fold these corner to corner, you'll also have lines of symmetry. Fortunately, this is centered at the origin. If it weren't, I'd have to do more work. But this is just y equals x, and the other one y equals negative x. 4 lines of symmetry. All of them are fairly easy to identify. Well, like I talked about it already, rotational symmetry is where you take this, rotate it around 360 degrees. You're going to see this appear 1, 2, 3, 4, 5 times before it goes back to itself. A Ferris wheel is probably the best one to think of because it actually is moving. The point of rotation is obviously going to be the point in the middle, and in this case, the point of rotation is 1, 2, and then it says how many times will it map onto itself in a 360 degree spin. Well, if you think about this, if you rotate it 180 degrees, it's going to be once, but then that's it. If you rotate it back around, you're not going to see it again. So this is only 1. With a 3-sided figure, it's probably going to be 3 times. I've already shown you the triangle. The center of spin on this one is side to side 0, up and down 3. A 5-sided figure will be 5 times. That's spinning around the origin. The square is also spinning around the origin. And again, a 4-sided figure we'll see 4 times. A is going to rotate once. It's frozen up. Once. Frozen up. And then twice, and then 3 times, and 4 times. Just a final look at some regular polygons that I've already been talking about. A triangle has 3 mappings. A heptagon, which is 7 sides, will have 7 mappings. You'll see it 7 times in a 360 degree spin.